Okay. So for these set of problems, it says perform the indicated operations and simplify the following. So I see that we have 8 to the power of 0 over 4, and it's negative, squared. So the first thing that I'm going to do is solve the inner layer and then work my way out. So I know that anything to the power of 0 is going to equal 1 because anything by itself equals 1. So I can also rewrite this as negative 1 over 4 equals 2. And now simply what's left to do is to distribute the 2 to both the numerator and the denominator. So I know that 1 squared is going to be 1, and 4 times 4 is 16. And the reason why I know this is positive is because another way that this can be written can be as negative 1/4 times negative 1/4, which is going to equal a positive number because it's a negative times a negative. That's how I know that it's positive 1/16 and not negative 1/16. So the key takeaway for that one is just remembering that anything to the power of 0 equals 1. So now we're going to do this one. And these are exponents. Sorry if it's a little hard to tell. But since these are exponents and they're being divided, what we're going to do is subtract them. So could also be rewritten as 2x minus 1 minus 3x plus 5. And now I'm going to distribute the minus onto the second expression. So it's going to be 2x minus 1 minus 3x minus 5. And now all that's left to do is to combine like terms, which is going to be 4 minus x minus 6. And the reason why the 4 does not, even though it's 4 over 4, the reason why it doesn't get simplified into 1 is because it just like doesn't make sense if it's 1, negative 6, negative 6, negative x, because whenever we have a 1, we just kind of turn it invisible so it's not there. So this just wouldn't make sense because this in hand would like disappear. So that's the reason why it's still 4, because we're just concentrating on simplifying, not necessarily solving. So we're just doing the exponent law of subtracting. Okay, here we're going to use the FOIL method, which is first, outer, inner, and last. Or the way I call it is like the 4 arrow method. So this is equal to 4x minus 3y times 4x minus 3y. This is the same thing. This is just the expanded form. And it's useful to expand it because you can only use the FOIL method or the method I'm about to show you when it's expanded to simplify. So you do first, which is going to get 16x squared. And I like to draw the arrows, the lines as I go, because if I draw them all at once, I'm going to get confused and forget what I already did. So first, and then you do outer. So this is going to be negative 12xy. You're going to do inner, negative 12xy. We're going to do last, plus y, 9y squared. And the reason why I don't like to do all 4 lines at the top or the bottom is because it looks really messy. And they kind of look like they're blending together. So just to organize myself and to not confuse myself, I do 2 at the top and 2 at the bottom. Doesn't matter which is which. And I see that we have common like terms that we can combine to further simplify it. And if you combine them, if you just add them up, it's gonna be negative 24 plus 9y squared. And then I see if I can simplify any further, and these aren't really divisible by anything, so that's when I know I stop. And again, it's just first, outer, inner, and last. Another way you could think about it is you have to multiply this by everything in the second expression, and then this by everything in the second expression. So, and then that's done because you multiplied. For example, if this had like a plus 5z, then that's when the FOIL method gets kind of, hypothetically, right? That's when the FOIL method gets kind of tricky. So that's when I would go by the thought process. Oh, I just have to multiply this by everything in here, and then this by everything in here. So that's just a little side note. Thank you.